Mars burns blood red against the black, a rusting world that once pulsed with rivers and seas. That crimson skin isn't decoration, it's oxidized iron, a scar from a planet that lost its air, its water, its magnetic heart. Every rover scoop screams death by chemistry, yet whispers of ancient life hide in the same red dust. Is red the executioner, or the undertaker preserving fossils for us to find? The visual assault, a planet painted in blood. Stand on the rim of Valles Marineris at local noon. The sky glows butterscotch from suspended dust. The ground screams scarlet. That hue dominates every orbital mosaic from orbiting spacecraft. The Martian palette is iron oxide by spectral weight. Earth rusts brown because water binds iron into different minerals. Mars, drier than the driest desert, oxidizes to pure red pigment. Dust grains are finer than powder. A single gale lofts them high into the thin air, scattering blue light and bathing the planet in perpetual ruby twilight. Sunset on Mars turns the sun into a pale blue dot behind crimson haze. The moons rise and set the same color. Red isn't a feature, it's the atmosphere itself. Forging the red blade, geologic autopsy. Rewind to the planet's birth. Mars forms hot, iron sinking to a core. A global magma ocean churns for millions of years, degassing carbon dioxide, water vapor, sulfur, and chlorine. An early dynamo spins a magnetic field strong enough to shield the young world. Fossils of that shield linger in southern cratered terrains, striped magnetic anomalies in ancient crust. Then catastrophe strikes. A massive impact excavates a gigantic basin, shock heating the mantle. Core convection stalls. The dynamo dies early. Solar wind, unopposed, strips nearly all of the atmosphere over hundreds of millions of years. Pressure collapses from thick and warm to thin and frigid. Water flashes to vapor, breaks apart in sunlight into hydrogen and oxygen. Hydrogen escapes, oxygen bonds with surface iron. A thick global rust rind forms, the regolith we see today. The peroxide crucible, chemistry's kill switch. Red dust is only the visible wound. Early landers added nutrient broth to soil. Oxygen gushed out. The soil contains hydrogen peroxide, far more than any Earth dirt. Sunlight splits peroxide into radicals that shred organic molecules faster than fire. One Martian day of sunlight delivers far more DNA-damaging radiation than Earth's surface ever sees. Gale craters' rippled sand contains perchlorates. Heat them, and chlorine gas erupts, destroying instruments. Perchlorates lower freezing points but dehydrate cells like cosmic salt. Earth's driest desert hosts microbes. Mars hosts almost none. Iron eaters. Could life have weaponized rust? Earth hosts bacteria that oxidize iron for energy, building rusty sheaths. Others reduce iron, exhaling different minerals. Mars' hematite blueberries in one plane look like bacterial concretions found in Earth deserts. Instruments confirm hematite and acidic minerals. Acidic lakes existed billions of years ago. Jezero Crater's delta, where the latest rover landed, preserves carbonate-capped ridges. On Earth, carbonates buffer acidity and cradle ancient microbial mats. Samples contain magnesite veins cutting basalt. Could microbes have oxidized iron while fixing carbon, painting the planet red on purpose? Red as byproduct, not barrier. Radiation, the silent scalpel. No ozone layer, no global magnetic field. Cosmic rays slam the surface constantly. Earth life tolerates brief high doses. Mars delivers chronic exposure. Even radiation-resistant bacteria need liquid water to repair damage. Mars water ice is frozen solid. Shielding comes with depth. A couple of meters of soil cuts radiation dramatically. Radar maps thick ice under plains. Radiation drops to Earth normal levels. Red dust above, ice below. A natural fallout shelter. Lava tubes collapse into skylights. Natural caves with thick roofs. Perfect habitat if groundwater seeps. The vanishing oceans. Where did the water go? Billions of years ago, Mars had a northern ocean deep enough to cover a fifth of the surface. Shorelines show wave-cut terraces. Radar finds tsunami deposits from impacts into liquid water. Water vanished through several paths, broken apart by sunlight and lost to space, locked in crust as hydrated minerals, frozen in polar caps, or hidden as subsurface brine. Radar recently detected a lake under the South Pole. salty enough to stay liquid in extreme cold. Perchlorate brines are toxic, but Earth microbes thrive in extreme salts. Could Martian life evolve pumps to handle the chemistry? Methane. Burps from the red grave. The latest rover sniffs methane, spiking after midnight, vanishing by dawn. Orbiters see no global plume. Source must be local. Red dust destroys methane quickly. Something replenishes it. Geology offers serpentinization, rock reactions producing methane. Ground-penetrating radar finds fractured basalt underground, possible reaction zones. Biology offers methanogens exhaling the gas. Clathrates trap ancient methane. Warming cracks ice, releases puffs. Red regolith seals the tomb until a drill bit breaks through. Preserving versus pulverizing, red as time capsule. Sunlight striking iron oxide forms superoxides that turn amino acids to charcoal. Yet crater mudstones preserve boron compounds that stabilize RNA backbones. Depth profile, shallow layers lose organics, deeper layers keep them intact. Samples from the delta show clay and aromatic compounds. Earth's ancient rocks preserve similar organics in clay. Red dust sterilizes the surface but acts as sunscreen. Radiation dies quickly with depth. Buried deltas become fossil gold mines. Terraforming the crimson demon. Reverse rust by reducing hematite with carbon monoxide and heat. Scale up oxygen production from the atmosphere. Neutralize perchlorates by washing soil with meltwater from polar caps. Seed extremophiles that eat perchlorates and release oxygen. Cyanobacteria can fix nitrogen even in thin air. Over decades, skies could shift from rust to pale blue. Red snow turns green under domes. But one dust storm recycles toxins. Terraforming's greatest challenge. Sample return, the final verdict. The current rover has cached dozens of tubes. A joint mission launches later this decade, returns samples early next decade. Earth labs will culture under controlled conditions, sequence any genetic material, and analyze isotopes to distinguish biology from geology. If life emerges, red was cradle. If only salts, red was coffin. Either way, Mars confesses in crimson. The red mirrors stare at Mars tonight. That dot isn't dead, it's a warning label. Earth's iron is locked in core and blood. Mars bleeds across continents. Lose your field, lose your air, lose your oceans. Gain a red shroud. Yet red also preserves. The mineral forms in warm water, habitable conditions. Acidic microbes on Earth paint rivers blood red. Mars' palette is a diary. I was warm, wet, alive, then I rusted. The question isn't why red, it's when. Past tense, life oxidized. Future tense, life oxidizes still, just below the rust, sipping brine, dreaming in methane. Red doesn't kill chances. It freezes them in time until a drill bit thaws the truth. The color is not an ending. It is a question mark etched across an entire world, daring us to read between the rust lines. Beyond the red veil, what the color conceals. Every rover image is filtered through red haze, but the story beneath is layered. Ancient flood channels carve the equator, evidence of catastrophic outflows that emptied lakes in weeks. Layered sediments in crater walls record cycles of wet and dry, like pages in a geological book. The red dust itself is a blanket, muffling the past while protecting it from the present. Consider the blueberries again. These spheres formed in groundwater, not wind. Water percolated through rock, dissolving and reprecipitating iron. On Earth, identical concretions grow around bacterial nuclei. The Martian ones are purer, but the process screams chemistry in liquid. Red is not just oxidation, it is evidence of saturation, followed by evaporation. The underground hope. Surface Mars is hostile, but the subsurface tells a gentler tale. Radar penetrates kilometers, revealing buried ice, fractured rock, and possible aquifers. Lava tubes snake under volcanoes, caverns hundreds of meters wide, roofs thick enough to block radiation and micrometeorites. If life retreated, it went down, not out. Red regolith insulates. Heat from the planet's interior could melt ice at depth, creating habitable zones where chemistry stays liquid. Perchlorates become energy sources. Iron becomes electron donor. Life wouldn't see red, it would live beneath it, in darkness lit only by chemical glow. Next time Mars rises in the evening sky, don't see a dead world. See a question frozen in iron oxide, a diary written in blood-colored ink, a dare to future generations. Dig beneath the red and read what the planet is still trying to say. The answer may not be green, it may be the color of rust itself, the hue of a world that almost made it and might still. If you enjoyed this video, make sure to subscribe to this channel for more content. Thank you.